Hi dear students, today we will derive an expression for time period of revolution of a satellite. So what is time period of revolution? Time period of revolution of a satellite means, say this is Earth, okay, mass of the Earth is me, and say there is a satellite of mass m at a particular height h, okay. Time required by the satellite to complete one revolution around the Earth. Time required by the satellite to complete one revolution around the Earth is called time period of a satellite. So how to calculate time period? Time period is equal to distance traveled in one revolution. Distance traveled in one revolution will be equal to circumference, okay, divided by speed. The speed with which satellite is revolving, that is orbital speed. So therefore, time period is equal to circumference, okay, 2 pi into what is the radius? The distance between the satellite and the center of Earth, okay. So this is also Re plus h, okay, Re plus h, okay, 2 pi into Re plus h means radius of this orbit, radius of the satellite orbit is Re plus h divided by orbital velocity. Orbital velocity is equal to v. Okay, so we know that orbital velocity is equal to, okay, 2 pi into Re plus h. Okay, so we know that orbital velocity is equal to square root of GRE square divided by RE plus H. GRE square divided by RE plus H. Now what we will do? We will bring this term to the numerator. So what happens? Time period will be equal to 2 pi into Re plus H. 2 pi into Re plus H into square root of Re plus H divided by GRE square. Re plus H divided by GRE square. So what happens? When this Re plus H goes inside the square root, it becomes Re plus H whole square. So we will get time period equal to 2 pi into, okay, this goes inside, it becomes Re plus H whole square, and one more Re plus H is there. So we will get Re plus H whole cube divided by GRE square. So this is the expression for time period. Now we can do some small approximation. What is the approximation? If the satellite is very close to the Earth's surface, then height of the satellite is very small compared to Re. Then what happens? Re plus H will be approximately equal to Re itself. Re cube divided by here one Re square is there. That Re square gets cancelled. So we get time period of revolution for a satellite which is very close to the Earth's surface is equal to T is equal to 2 pi into square root of Re divided by G. Thank you very much.